All right, let's dive in. Today we're looking at safety concerns and mitigation approaches regarding the use of deep learning in safety-critical perception tasks with a focus on autonomous driving.
Quite a mouthful.
It is a bit, yeah, by Oliver Willers, Sebastian Sudholt, Shervin Raafatnia, Stephanie Abrecht, and Robert Bosch, GmbH.
Bosch, yeah,
And now knowing our listeners, they're deep into math, machine learning, data science.
absolutely.
So we're gonna get right to those core ideas, those concepts, the real meat of it. What did you find most interesting about this paper?
Well, it's dense, I'll give them that, but
Yeah.
it gets right to a really, really important tension. This idea that deep learning is incredibly powerful, right? Especially for these perception tasks in autonomous driving.
Okay.
But that power comes at a cost. And the cost is that it's really, really hard to understand what's going on under the hood, which
Black box problem we always hear about.
exactly, and that is a huge safety challenge.
Right, because like if you can't understand why it's making decisions, how can you trust it to, drive a car with people in it?
Yeah, it's a tough one.
So let's back up just a bit. For context, you know, why is deep learning so important for self-driving cars in the first place?
Well, because it's really good at solving problems that we can't really define with rules, Problems that have like an open context, like recognizing a pedestrian under any condition you can imagine, like lighting, weather, if they're partially hidden.
Right.
You name it, deep learning can handle that complexity where traditional algorithms would really struggle.
Yeah, because it's not like you can write a program that says, if you see two legs and a head, that's a person.
Right, exactly. There are just too many variations, too many edge cases.
Right. It's got to learn from the data. It's got to see tons of examples to really get it.
Yeah, and that's the beauty of it, but it's also, where the black box problem comes in.
So it's like, it's great at learning, but we don't always know what it's learned or how it's applying that knowledge.
Yeah, and that's a big problem when you're talking about a system that's making life or death decisions on the road.
So how does this paper try to address that? You mentioned, it's a dense paper,
It is.
but like where does it even start?
Well, it starts by laying out 9 very specific safety concerns. They call them SC1 through SC9.
Okay, well, let's walk through those. I mean, that sounds like a good place to start.
Yeah, it's a good framework.
So SC1, what's the first one all about?
It's all about the training data, the data that's used to teach the deep learning model.
Okay.
And the concern is that this data might not fully represent the real world.
Makes sense. I mean, if you only train it on, perfect sunny days in California, it's going to freak out when it sees snow in Boston.
Exactly. And that's a huge risk because you don't want your self-driving car to encounter a situation it's never seen before.
Right. And then SC2.
So SC2 kind of takes that idea a step further. It's about the fact that the world is constantly changing, right? And the data we use to train these models is static, like it's a snapshot in time. So you have new car models, road construction, even just like...
Yeah, like new traffic laws.
Exactly. And all these things can create what they call a distributional shift, which means the real world is different from what the model was trained on.
Okay, that's starting to get a bit technical, but I think I follow.
Yeah, it's basically saying the world keeps moving, but the model is stuck in the past.
Right, like it's learned from old data, and now it's got to deal with new data.
Right, and that can lead to all sorts of problems.
All right, so that's 2 of the safety concerns down. What about SC3?
Back to the black box problem.
Oh, boy.
This one highlights how the lack of transparency in the model's decision-making process makes it really hard to predict or prevent potential failures.
Okay, so it's like we can't see what's going on inside the AI's brain,
Yeah.
so we don't know why it's making the choices it's making.
Exactly, and that makes it really hard to fix problems or anticipate new ones.
Like, it's one thing to know that the car made a mistake. It's another to understand why it made that mistake.
Right, and that why is crucial if we want to make these systems truly safe.
Yeah, I can definitely see that. So it's not enough to just make sure the car doesn't crash. We also need to understand the logic behind its actions.
Absolutely. And that leads us to SC4.
Okay, hit me with it.
SC4 is all about those rare, critical situations that might not even show up in the training data.
Like what?
Like a child suddenly running into the road from behind a parked car. If the model's never seen that before, it has no idea how to react.
Oh, that's a terrifying thought.
Yeah, and that's the danger with deep learning. It's only as good as the data it's trained on.
All right, so that's 4 out of 9. This is getting pretty heavy.
Yeah, it's a lot to digest.
But it's important stuff.
Oh, absolutely. This is the cutting edge of AI safety research.
So let's keep going. SC5, what's next on the list?
SC5 is all about overconfidence.
Overconfidence. How can an AI be overconfident?
Well, believe it or not, these deep learning models can be surprisingly sure of themselves even when they're wrong.
Okay, like a student who aces all the practice tests but then bombs the real exam.
Exactly. And that's a big problem because you don't want the AI to be overly confident in a situation where it doesn't really know what it's doing.
Right, like if it misclassifies a stop sign as a speed limit sign, that could be disastrous.
Exactly. And that brings us to SC6, which is kind of related.
Okay, so what's SC6 about?
It's about brittleness.
Yeah.
The idea that even small changes to the input data can lead to big errors in perception.
Oh, I've heard about this. Like those adversarial examples where you can like change a few pixels in an image and completely fool the AI.
Exactly. And that's a big concern because it shows how easily these models can be tricked, even by subtle changes that a human wouldn't even notice.
So it's not just about the data itself, it's about how the AI processes that data and how sensitive it is to even tiny variations.
Exactly. And that makes it really challenging to ensure that these systems are robust and reliable in the real world.
Okay, so we're up to 6 safety concerns. What's next?
SC7 focuses on the evaluation process itself. It highlights the risk of using test data that's too similar to the training data.
Oh, I see. So it's like if you only test the AI on data that's already seen before, you're not really getting a true measure of its performance.
Exactly. It's like practicing for a race on the same track every time. You might win the practice races, but you haven't really proven your skills.
Right, you need to test it on a variety of tracks, different conditions to really know how good you are.
Precisely. And the same applies to deep learning models. We need to test them on data that's diverse and representative of the real world, not just data that looks like what they've already seen.
Makes sense. Okay, so 2 more to go. What's SE8 all about?
SE8 is all about data quality, specifically the risk of errors in data labeling.
Oh, right, because if the data is labeled incorrectly, the AI is going to learn the wrong things.
Exactly. And even small errors in labeling can have a cascading effect on the model's performance.
Okay, so garbage in, garbage out, basically.
Pretty much, yeah. And it highlights the need for really rigorous quality control measures when it comes to data annotation.
Okay, so that's 8 safety concerns down, 1 more to go.
SC9, the final one, focuses on the limitations of traditional performance metrics.
Okay, like what kind of metrics?
Like overall accuracy, for example.
Mm-hmm.
The paper argues that focusing solely on average performance can mask critical failures in those rare high-risk situations.
Right, because the system might be 99% accurate overall, but still make a fatal mistake in that 1% of cases.
Exactly. And that's why we need metrics that specifically assess the model's ability to handle those edge cases, those situations where safety is paramount.
Wow, that's a lot to think about. 9 distinct safety concerns, all related to deep learning and autonomous driving.
Yeah, it paints a pretty sobering picture.
It does, but it also feels like, they're not just pointing out problems, they're trying to find solutions.
Oh, absolutely. And that's what we'll dive into next. The paper actually presents a whole set of mitigation approaches, strategies for addressing each of these safety concerns.
That's what I like to hear, because this is getting pretty heavy.
Mm-hmm.
All right, so let's take a break there. Give our listener a moment to, absorb all of that.
Yeah, I probably need a coffee after that.
And when we come back, we'll dive into those mitigation approaches and see how we can start tackling these challenges head on.
Sounds good to me.
All right, we'll be right back after a short break. Okay, so deep breath. We just went through those 9 safety concerns. That was a lot.
It was a lot, yeah.
But now we're going to get to the good stuff, the solutions, the mitigation approaches that the paper lays out.
Right, because it's not all doom and gloom.
Exactly. There's hope.
There's hope. There's a lot of smart people working on this stuff.
Okay, so let's start with the first one, MA1. What is that all about?
So MA1 is all about tackling that first concern, the data representativeness problem.
Okay, right. The training data not matching the real world.
Exactly. And the solution they propose is to develop a really, really rigorous data acquisition strategy.
Okay, so not just collecting tons of data, but making sure it's the right kind of data.
Right. It's about capturing the full spectrum of what they call the operational design domain, or ODD.
ODD. Now that sounds kind of technical.
It is a bit, yeah, but it basically means all the possible scenarios the self-driving system might encounter.
Okay, so like weather conditions, road types, traffic patterns, all that stuff.
Yeah, all of that. Lighting conditions, pedestrian behavior, you name it.
So the goal is to create a data set that really reflects the diversity and complexity of the real world, not just like a simplified version of it.
Exactly. And they even talk about using some pretty advanced techniques to analyze the data and identify potential gaps or blind spots.
Oh, like where they might need to collect more data.
Yeah, exactly. So it's not just about quantity, it's about quality and coverage too.
That makes sense. Okay, so that's MA1. On to MA2. What's that one all about?
MA2 tackles that overconfidence problem we talked about.
Right, the AI being too sure of itself.
Yeah. And the solution they propose is to build in a mechanism for reliable confidence estimation.
So basically, the AI needs to be able to tell us how certain it is about its predictions.
Exactly. So instead of just saying pedestrian crossing, it would also say, I am 95% confident that's a pedestrian crossing.
Okay, so it's like it's giving us a measure of its own uncertainty.
Exactly. And that allows for more nuanced decision making.
So if it's really confident, it can proceed. But if it's not, it might slow down or ask for help.
Yeah, exactly. It's about knowing its limits and communicating those limits effectively.
That's pretty smart. All right, so that's 2 down. What about MA3?
MA3 is where things get really interesting. This one's all about trying to peek inside that black box.
Ooh, now we're talking. How do they propose doing that?
Well, they talk about a bunch of different gray box methods, which basically means techniques that give us some level of interpretability without completely sacrificing the power of deep learning.
Okay, so it's like we're not going to get a full explanation of what's going on in there, but we can at least get some clues.
Right. And some of these methods involve visualizing the parts of the input data that are most influential in the model's decision-making.
So like seeing what the AI is paying attention to.
Exactly. Like if it's looking at an image of a street scene, it might highlight the areas that led it to believe there's a pedestrian there.
Oh, that would be really helpful.
Yeah.
So we can see if it's focusing on the right things.
Yeah, exactly. And other methods involve forcing the model to provide more interpretable outputs.
Like instead of just saying car, it might say sedan, red, parked.
Yeah, exactly. That gives us more insight into its reasoning process.
I like that. It's not a perfect solution, but it's definitely a step in the right direction.
It is. It's about making these black boxes a little less opaque, a little more understandable.
Okay, so that's 3 down. What's MA4 all about?
MA4 is all about defending against those adversarial examples we talked about.
Right, the trick images and stuff.
Yeah, exactly. And they suggest taking a proactive approach.
Okay, so like anticipating the attacks and building in defenses beforehand.
Exactly. They talk about specifying potential threat models, like the types of attacks that might be possible, and then developing robust defenses.
So we're basically thinking like the bad guys, trying to figure out how they might try to fool the system.
Yeah, in a way. And they also emphasize the importance of considering physical adversarial examples.
What are those?
That's where the attacker manipulates the real world, not just the digital data.
Oh, okay, so like putting a sticker on a stop sign to make it look like something else?
Exactly. That's a physical adversarial example.
That's kind of scary, actually.
It is, yeah. But luckily, there are some promising defenses being developed.
Like what?
Well, one approach is called adversarial training.
Okay, and what is that?
It's where you deliberately expose the model to adversarial examples during training.
So it learns to recognize and resist them.
Exactly. It's like giving the AI a crash course in spotting fake news.
That's a good analogy. Yeah. All right, so that's 4 mitigation approaches down. What's MA5 all about?
MA5 is all about testing.
Testing. Okay, that seems pretty straightforward.
It is, but it's also incredibly important.
I imagine so. I mean, you can't just release a self-driving car onto the road without testing it thoroughly.
Exactly. And they emphasize the need for rigorous testing that covers both known and unknown scenarios.
Including those rare critical situations we talked about.
Absolutely. They talk about testing in a variety of environments, pushing the system to its limits, and even introducing unexpected events to see how it responds.
So it's like testing for the expected, the unexpected, and everything in between.
Precisely. And they even suggest using some structured techniques to identify potential failure modes and develop targeted test cases.
Okay, so it's not just about driving around randomly and seeing what happens. It's about being very systematic and deliberate in the testing process.
Exactly. It's about leaving no stone unturned.
All right, so that's 5 down. On to MA6. What's that one all about?
MA6 focuses on the analysis of the test results.
Okay, so it's not just about whether the system passed or failed. It's about understanding why.
Exactly. It's about digging into the data, understanding why the system behaved the way it did, and using those insights to improve the model.
So it's like detective work, almost.
Yeah, in a way. And they highlight the importance of focusing on cases where the system made mistakes or was uncertain.
Right, because those are the cases where we're most likely to learn something valuable.
Exactly. It's about turning those failures into learning opportunities.
I like that. Okay, so we're up to 6 mitigation approaches. What's MA7 all about?
MA7 is all about data partitioning.
Data partitioning. Now, what is that?
It's about how we divide the data into different sets for training, validation, and testing.
Okay, and why is that important?
Well, remember that concern about using test data that's too similar to the training data.
Right, the practicing on the same racetrack problem.
Exactly. MA7 is about making sure that doesn't happen.
So how do they propose doing that?
They suggest using data from different sources, different times, different sensors, even different vehicles.
So the test data is truly representative of unseen real-world scenarios.
Exactly. It's like having a separate panel of judges for the final competition to make sure it's fair.
Okay, that makes sense. All right, so that's 7 down. What about MA8?
Back to data quality.
Again.
Ugh.
Okay, but we already talked about data quality with, was it SC8?
We did, but this one's specifically about labeling.
Right, making sure the data is labeled correctly.
Exactly. And they really emphasize the need for strict guidelines and quality control measures.
So it's not just about having lots of data, it's about having lots of good data.
Precisely. It's like making sure the AI is learning from a reliable textbook, not some random scribbles.
That's a good analogy.
Yeah.
Okay, so 2 more to go. MA9, what's that one all about?
MA9 focuses on performance evaluation.
Okay, so how we measure how well the system is doing.
Exactly. And they argue that we need to go beyond those traditional metrics like overall accuracy.
Right, because a system might be 99% accurate, but still make a fatal mistake in that 1% of cases.
Exactly. We need metrics that specifically assess the model's ability to handle those edge cases, those safety-critical situations.
So how do we do that?
Well, they suggest developing metrics that focus on things like time to collision, deviation from a safe path, or the frequency of critical interventions.
So basically, we're judging the AI on its ability to avoid disasters, not just on how smoothly it drives on a sunny day.
Exactly. It's about measuring the things that really matter when it comes to safety.
That's good. All right, so that's 9 down, 1 to go. What's the final mitigation approach?
MA10 is all about continuous learning and updating.
Okay, so it's not just about building a good system. It's about making sure it stays good over time.
Right. The world is constantly changing, so the AI needs to be able to adapt.
So how do we make that happen?
They talk about building in a system for continuous data collection and analysis.
So the AI is constantly learning from new experiences.
Exactly. And they suggest using that data to retrain the model, so it's always getting better.
It's like giving the AI a lifetime subscription to an online driving academy.
I like that analogy. It's about recognizing that safety is not a destination, it's a journey.
Well said. All right, so there we have it. 10 mitigation approaches, each designed to tackle a specific safety concern.
It's a comprehensive roadmap.
It is. And it's clear that ensuring the safety of deep learning in autonomous driving is a complex and ongoing challenge.
It is, but it's a challenge that I'm confident we can overcome.
I hope so, for all our sakes.
Yeah, me too. This is really important work. It has the potential to save a lot of lives.
It's a lot to take in. 9 safety concerns, 10 mitigation approaches. It really shows you how much work goes into making this technology safe.
Yeah, no kidding. It's a really complex problem.
But I do feel like this paper gives us, a sense of hope, right? Like they're not just throwing their hands up and saying, it's too hard.
Right, yeah. They're identifying the problems and they're coming up with concrete solutions.
Exactly. It's like a roadmap,
Yeah.
right? A guide to making deep learning and autonomous driving as safe as possible.
Yeah, I think that's a good way to put it. It's a roadmap.
Okay, so roadmap in hand. What are your big takeaways from all this? Like what's the key message you want our listener to walk away with?
Well, I think the biggest takeaway for me is that safety is not an afterthought.
Okay.
It's not something you just tack on at the end. It has to be built into the system from the ground up.
Right, like it's got to be a core design principle.
Exactly. And this paper really highlights that, in a very concrete way, it's not just about having a good deep learning model. It's about having the right data, the right testing procedures, the right evaluation metrics.
Yeah, it's about the whole ecosystem around the model.
Exactly.
And I think that's what makes this paper so valuable.
Sure.
It's not just for, engineers who are building these systems.
Right.
It's for anyone who's interested in the future of AI
Yeah.
and the ethical and societal implications of these technologies.
Absolutely. I mean, self-driving cars are going to change the world, right?
Yeah, big time.
And we need to make sure that they change it for the better.
Right. We need to make sure they're safe, reliable, and beneficial for everyone.
Exactly. And I think this paper, it's a really important step in that direction.
Well, I think that's a great place to leave it. This paper has given us a lot to think about, and I hope it sparks some interesting conversations among our listeners as well.
Yeah, me too. It's a fascinating topic.
It is, and it's one that we're going to keep exploring on this show, so stay tuned for more deep dives into the world of safe and responsible AI.
I'm looking forward to it.
All right, thanks for joining us on this deep dive. Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible with AI.
See ya.